Hi everyone, have a great day ahead. In this video, let us see the different scheduling algorithm present in operating system. The operating system is designed by different scheduling algorithms. Based on the user request, scheduling algorithm will be used. So, the different types of scheduling algorithm that is present in operating system are first come, first serve scheduling, FCFS scheduling, shortest job first scheduling, SJF scheduling, and then priority scheduling. And the last one is round robin scheduling, that is RR scheduling. So these are the different types of scheduling algorithm that are present in operating system. In this video, I am going to explain the first algorithm, that is first come first serve scheduling algorithm. What is it saying? The process that comes first that has to be executed first. In this example, this is the process I am taking and this is the burst time. I am taking three processes, P1, P2 and then P3. And these are the burst time of those processes. What is process? The program that is currently being executed, that you call it as a process. What is burst time? Burst time means that how much time CPU is handling this process, that you call it as a burst time. Suppose the processes arrive in order P1 and then P2 and then P3. So how it is going to occupied? The first one is P1. The burst time of P1 is 0 to 24. The burst time of P2 is 3. If you add 3 with 24, it would become 27. And the burst time of P3 is 30. Now let us calculate the waiting time of each process. The process that is waiting in the queue, that you call it as a waiting time. Now let us calculate the average waiting time. The average waiting time of this FCFS process is calculated by adding 3 burst time and dividing it by 3. You will get 17 as your answer. So 17 is the total average time of this process that has to be executed in the CPU. In this process, I am taking the order like P1 and then P2 and then P3. Suppose the process will arrive in order P2 and then P3 and then P1. So how this process is going to be occupied? Here we are taking P2 as the first process and then P3 and then P1. So starting from P2, the burst time of P2 is 3. So 0 to 3. The burst time of P3 is 3. So 3 plus 3 is 6. The burst time of P1 is 24. So 6 plus 24 is 30. So we are going to calculate the waiting time. Waiting time of P1 is 6, P2 is 0 and then P3 is 3. So when we calculate average time of this process, we will get 3 as an answer. So average time of two processes will difficult. So if you take the order as P1, P2, P3, the average time will be 17. If you take order as P2, P3, P1, you will get average waiting time as 3. So let us see the problem arising in the FCFS algorithm. The first problem is that it is a non-preemptive algorithm. Why I am saying that it is a non-preemptive algorithm? Because the process has no choice. It has to be execute the process which is present in the queue next. Whatever the process that is waiting in the queue, that process has to taken by the CPU. There is no option for the CPU because here we are not considering the priority. So that's why FCFS is a non-preemptive algorithm. The process priority doesn't matter here. And the second one is improper process scheduling. So if we take a process in an order of P1, P2, P3, you will get one average time. If we take a process with the same burst time in an order of P2, P3 and then P1, you will get another average time. So it is an improper process scheduling. Resource utilization in parallel is not possible, which leads to convey effect. What is convey effect? Due to some slow process, the whole OS is going to be down. That you call it as a convey effect. Thank you.